डॉक्टर बाबा साहेब आंबेडकर ओपन यूनिवर्सिटी।
Namaskar, I, Dr. Darshna Dalwadi, is welcoming you all. Paper 105, Software Engineering, Block 2, Unit 1, Software Measurement and Estimation. Dear learners, in previous lecture we were discussing this software measurement and estimation only. In this lecture, we will have let us first discuss that whatever we have discussed in previous lecture. In previous lecture, we were having the discussion of software size measures. We were having two measures, LOC and FP. LOC stands for line of code and FP stands for function points. LOC is considering only the source codes which we are having, means we are skipping the comment lines as well as the blank lines. And we discuss about its advantages, disadvantages. FP, how it is useful, its advantages and disadvantages. In today's lecture, we are going to discuss upon FP calculation and software cost estimation. Now, let us start our discussion with FP calculation. Now, when we are talking about these function points, at that time, first we need to understand that what is function point, which we have already discussed. And now we will understand that how exactly function points are calculated. Some steps are given to you for calculating FP. Now, first step we have, that is all functional requirements which we are having in our software are categorized into 2 data functionalities and 3 transaction functionalities. So, in first step what we are doing, first step contains the categorization of all functional requirements. It will be either data functionalities or it will be transaction functionalities, or also known as elementary processes. Step 2 is complexity levels. Whatever functionalities we have, to it the complexities are assigned, and based on the how it will be assigned, it will be assigned based on the guideline which is provided for each data functions and elementary processes. Whatever we have defined in step 1, for it we will have one guideline based on which the complexity will be decided and will be assigned to it. Third step we have, calculate unadjusted function points for the entire product by adding individual functionality level FP after applying complexity weightages. How to calculate it, it will be covered in detail in next discussion, but these are the overview of the steps, how you will have the steps. So, in third step we are actually calculating the unadjusted function point. Fourth one we have, that is calculate value adjustment factor based on degree of influence of 14 general system characteristics. Whatever general system characteristics you have, based on it you are going to calculate the value adjustment factor, VAF. And fifth one is calculate final adjusted functions point for the entire software product. So, these are the steps given to you for calculation of FP. Now, let us move to the detailing of this software's calculation steps. First one we have, that is identify and categorize functionalities. Functionalities are categorized into main 2 categories. First one is data and second one is transaction, means data functionality and transaction functionalities. Transaction functionalities are also called as elementary processes. Now, in data functionalities what we have? As I said you in first step, that when we have this one, first step, we will have 2 data functionalities and 3 transaction functionalities. So which are the 2 data functionalities? First functionality we have, that is internal logical files, ILF. It is user identifiable group of data logically related and maintained within the boundary of the application through one or more elementary processes. What is internal logical files, ILF? It is user identifiable group of data which is logically related and maintained with the boundary of the application with the help of elementary processes. And second data functionalities we have, that is external interface files, EIF. It is user identifiable group of data which is referenced by the application but not maintained within the boundary of the application. See the difference, internal logical file and external interface files. Both are user identifiable group of data only, but ILF is it is maintained within the boundary of the application, while external interface file, EIF, is not maintained within the boundary of the application. ILF and EIF can contain business data, control data and rules based data. Which type of data it will contain? It may contain 3 type of data. It may be business data, it may be control data, or it may be rules based data. Then after, second type, that is transaction functionalities or elementary processes. Now in this what we have, elementary process is the smallest unit of activity which is self-contained and meaningful to the user. It constitutes the complete transaction and leaves the business of the application in consistent state. So a functional requirement like maintain student information. Your functional requirement is this, maintain student information. When you are talking about this, it can be decomposed into add students, change student information and delete student, as well as inquire about student. Your requirement is only one, maintain student information, but to maintain it you have to do these 4 things: add, change, delete and inquire. So these are the functional requirements you will have for these are the transaction functionalities or elementary processes you will have for one function. Now when we are talking about this, at that time 3 types of categories we have, which is called as elementary or transaction functionality. First one we have, that is external inputs, EI. It is an elementary process in which data comes from output, or we can say come from outside to the process. And from where it can come? It can come through input screen or any other application. As the name suggests, it is external input, means from somewhere out it is coming in your process or in your system. It maintains one or more ILF. Now what is the meaning of ILF? We have already discussed. Here we have seen ILF, internal logical files, EIF, external interface files. So when we are talking about this external inputs, EI, it may maintain one or more ILF. It may not maintain ILF if the data is only control information. Now we have seen that we may have 3 type of data: control, business, right? So if the data is only of type control, then it will not maintain any ILF. If it provides functionality of add, change and delete, then they all are three considered, all these three are considered separately. Second one we have, that is external queries, EQ. EQ is an elementary process in which data is retrieved from ILF or EIF and sent outside without processing. It can have both input and output components, which may result in data retrieval from one or more ILF or EIF. The input which you are having in it does not update or maintain any FTR, and the output side does not contain derived data. If such type of elementary process you have, then it is called as the external query, EQ. Third one we have, that is external output, EO, an elementary process in which data is retrieved from ILF or EIF, processed or derived, and passes from internal processes to outside. It may be in the form of report or it may be in the form of output file, which are sent to other applications. The derived data does not appear in FTR. This thing we have in first step, means we have categorized the functionalities in data and transaction functionality, data functionality and transaction functionality. As the name suggests, you try to understand that if data functionalities are there, then it will be related to data only, and transaction functionalities are there, then it will be related to transaction, means some processes will be there. Getting? This is the representation of connection between EI, EQ, EO, ILF, EIF. Interface application you have, then you may have ILF. Application being measured, if you are measuring the application, then you can have this ILF, different ILFs, and based on that you can have the measurement. Second step we have, that is assign complexities to each function. Now you have assigned the functions, you have derived it, you have divided it. Now you have to assign the complexities. Whatever guideline you are having, which we are going to discuss, based on that only you are going to assign the complexity to each functions. First one we have, that is assign complexities to data files. To determine complexity level of data functionalities, record element types RET and data elements DE are considered. Now first we are going to see DET, that is data element type. Two types you have to consider for assigning complexity to data file: record element and data element. First we have, that is DET, that is data element type. It is a unique, user recognizable, non-recursive and non-repetitive field. DET is a field that is dynamic, and DET can also be in the form of photograph, sound or any other thing. You can say unique identification of user, that can be DET, data element type. Now what is the meaning of RET? Record element type is a user recognizable subgroup of data elements within an internal or external file. It would be logical grouping of data. It represents number of files or tables which are required for storing DETs. To store DET, whatever files or records you require, it may be your RET. For example, to understand this, what we can say, let us say that if we have to store information of student, we may require one RET, but if we also want to store history of students' education, we may require more than one RET. entity is same, student is same, but if we want to store the information of student as well as the history of the education of student, then you require 2 RET. Depending on functional requirement to store data, we have number of RETs. Likewise, all the information we want to store, we need to consider number of DETs and RETs for each. It depends which type of data you want to store. Based on that your DET and RET will be decided. Here one example is given to you how the complexities will be there for each function. Here we can see one file we have, that is internal logical file, that is ILF, and one table we have for external interface files, in which it is showing you that if you have RET value and data elements in it, then how much complexity level you will have. Suppose your RET is 1 and data elements you require is 1 to 19, then its complexity is low. L is representing low, A stands for average, and H stands for high. Now suppose your RET is 1 and data elements you have are 20 to 50, then it will have low complexity. RET is 1 and your data elements are greater than 50, then it will have average complexity. Moving forward, suppose your RET is 2 to 5 and data elements are 1 to 19, then complexity will be low. RET is 2 to 5, data elements are 20 to 50, then your complexity will be average. RET is 2 to 5, data elements are greater than 50, then your complexity will be high. And suppose your RET is greater than 5 and data elements are 1 to 19, then the complexity will be average. RET is greater than 5, data elements are 20 to 50, then complexity will be high, and so on. You can see that if you are having this internal logical files, then how your complexity levels are. Now you may have the question that how we have decided that L, A and H. For it we will have one guideline. Based on that we have to decide that this will have low, this will have average, and this will have high complexity. Same as internal logical file, we are having external interface files. For that also we have given one table here which you can refer. Moving forward, to determine complexity level of transaction functionalities like EI, EO, EQ, file type references and data elements, we have to consider. Now in DET, what we have? DET is a unique user recognizable non-repetitive field which is used in this process. For input process, it can be number of fields or on the screen. This also includes buttons on the screen. Now here we are talking about considering the complexity level of transaction functionalities. So you have to consider this EI, EO, EQ, file type references, FTR, as well as data element types. So we are first understanding that how data element types are used for determining complexity level of transaction functionalities. Now when we have this DET, at the time we have already discussed that it is a unique user identifiable or user recognizable non-repetitive field which is used in this process. For input process, it can be number of fields on the screen. Whatever number of fields you are able to see on your screen, that can be your DET. This also includes buttons on the screen. Second thing we have, that is FTR, file type references. Now FTR is reference by a transaction. It represents how many internal or external files or tables are impacted by those DETs, whichever are in process. After that we have in FTR other thing what we can consider. An FTR is either ILF or EIF. FTR can be this one also, means it is a reference which is it is a one type of transaction which is referencing to some table or external files, or it may be ILF or EIF. Each ILF that is maintained by external input is counted as an FTR. An ILF or EIF that is referenced by the processes are also considered as separate FTR. For example, if an external input may update an internal logical file but also refer to security file to check that the user has proper security level, then both the things, that external input file means which is updating internal logic file, as well as it is also having the effect in security file, then both the files will be considered as FTR. After that, here one different tables are there which are given to you to understand that if elementary input you have, elementary output you have, and elementary queries you have, then how the complexities will be assigned to them. These are for EI, EO and EQ, right? The complexity levels are as same. L stands for low, A stands for average and H stands for high. And these tables are provided by IFPUG, International Function Point User Group. If your FTR is less than 2 and data elements are 1 to 4, then your complexity will be low. Let's say if your FTR is 2 and your data elements are greater than 50, then the complexity will be high. And for elementary input, suppose you are having FTR greater than 2 and data elements are 5 to 15, then you will have complexity as high. For elementary output, suppose your FTRs are less than 2 and the data elements you have are 6 to 19, then you will have low complexity. Suppose you are having FTR 2 or 3 and your data elements are greater than 19, then you will have high complexity. And if your FTR is greater than 3 and your elementary outputs, data elements are 6 to 19, then the complexity of this will be high. For elementary queries, suppose your FTR is less than 2 and your data elements are 6 to 19, then it will have low complexity. Suppose for FTR greater than 3, you have data elements which are greater than 19, then you will have high complexity. So these are the complexities we have for EI, EO and EQ. Now moving to the third point, that is calculating unadjusted function points. Now when we are trying to find this, at that time we have to apply the complexity weightages based on its category. Each function is then assessed for its complexity level and a weighting factor is assigned according to the derived unadjusted function point for the project. Here you can see we are having complexity weightages for EI, EQ, EO, ILF and EIF for 3 different categories of complexity: low, average and high. Now these numbers which we are having are weighted complexities, and based on that we are going to calculate the average of this, means we are trying to find unadjusted complexity. Now let us assume that we have been able to categorize various functions into elementary processes and data files as described here, and also categorize them into complexity level according to this table. So here you can see inputs we have inquiries, output, internal files, external files. For low, average and high we have three different numbers, and it is having one column called as total, which is giving you the total of inputs, total of inquiries, total of output, total of internal file and total of external file. Now for this type of table, when we are going to calculate it, at that time what we have to do? In this we will consider the weighted points which we are having here. See here in this slide you can see complexity weightages are given to you 3, 4, 6, 3, 4, 6, 4, 5, 7, 7, 10, 15, 5, 7, 10. These things you are going to calculate with this one. This is what number of processes and files, total number of files whatever you have is given in that. Now here you can see the calculation of unadjusted function point. Getting what we have done? Whatever input files we have, total input files, here you can see in first one input is 10 and its weightage complexity is 3. So 10 into 3 is equal to 30, and so on. We have multiplied the data files with the weighted complexities, and finally we are getting the total. So at the end whatever answer we are getting, that is 524, that is the adjusted function point which we have calculated for this given type of data. So you can calculate it according to your data. So this is the point 3 where we are able to find unadjusted function points. Based on that we will be getting the fourth step in which we are getting the function point value. So today we are keeping up to this. In next lecture we will continue with the remaining steps, step 4 and step 5. Till that, namaskar.